Hi everybody. Today we're gonna be looking at Groq versus Calgary rents. Now, what does that mean? Well, we're gonna be using AI to basically just look at a bunch of rental rate stuff and tell us what it thinks. We will be using large language models. We will be using them through Groq, and we'll be applying it to Calgary rental rates. We'll be using a very similar data to some of my other recent videos, so check them out, and let's get to it. Okay, so the first thing that we're gonna do is we're gonna install that Groq. Now, what is Groq? Groq is like an intermediary. They run large language models on their own hardware, and it's really advanced hardware. So that's what they are. Let's do our imports. Don't need that guy anymore. And then we'll start looking at our data a little bit. So like I said, we're looking at the same data set, or at least a very similar data set as in my recent other videos. And they are Calgary rental listings. So as you'll notice, we've got 6,000 items in the data. I'm printing off the tail 1000 here. Oh man, I didn't mean to do that. We'll print off the the tail 50. Now you can see this column right here is the rental rate, the price. So as you're looking through the details here, just bear in mind that we're at the bottom of the list where all the highest rents are. So, you know, seeing 5+ den that's not normal, right? You know, $6,000, you know, rent duplex, you know, that's not a $6,000 condo, you know, come on. So this is the data set that we're going to be allowing the large language model to basically interpret and look at. So let's just move on. I am copying off of a pre-written script that I have. That way it's just easier for me, and I'm not fumbling around in front of everybody all the time. So let's just make sure everything's working here. Okay, so one thing that we have to do is we're gonna end up having to cut the string down. That's why I had this like this earlier. So let's just get that back, and we'll put a 1, and we'll go like that. Now let's just do the full data frame and convert it to string, so that we can see what the length of what we're working with is in characters. So we're dealing with 1 2/3 million characters. This is going to come in this is going to be important to know later, because we are going to max out the allowance on the large language model. And so I'm just going to demonstrate what that looks like a little bit later on, but just bear in mind that the full data frame is about 1 2/3 characters. These large language models tend to use tokens rather than characters. So think of a token as like, I don't know, 3, 4, 5 characters. Okay. So we're putting the data frame into these variables, you'll notice I've got 4 different versions of what we're going to look at. So we will be looking at a few different items. And I'm just checking out my Groq key here. So let's start forming the actual prompt. Okay, so this is the prompt. And of course, we're missing the C. There we go. So I have several things that I can say to the large language model, and we'll go through that in a sec, but let's just look at the structure here. So I'm basically sending this stuff here, everything that's in the message, to this large language model. So Groq is giving us access to their hardware where they already have several models loaded. This is the one that we're going to look at today because it has the highest allowances, and because our data frame is fairly large in a token measure, it just makes sense to use one that's fairly kind of lean. There are a few larger, more recent models, but we're not going to be looking at those right now. So we have the system prompt, which kind of tells the large language model how it's expected to behave. We're giving it 3 instruction sets that are kind of like direct commands. So after providing context, we then give instructions. So I'm telling it what I'm about to give it. I give it the data frame that we've just looked at, and then I make a request, And here, of course, we just print it out. So let's get started and see what Llama 3.8b has to say about Calgary rental market statistics. Oh, and just let's just look at this for a sec. So right now I've told it that they are a stressed out real estate genius. And that I am giving them a bunch of real estate rental rates, and I'm asking it to give me statistics about rentals in Calgary. So let's see what we get. Oh, come on. Oh. Is this the... Yeah, rate limit error. Right. Yeah, sorry. Okay, there you go. So I guess I showed you faster than I had intended, because I forgot to set back our data frame. We're still working with the full thing here, folks. So let's comment. Okay, and we're back, and I gotta be honest, that took an embarrassingly long time to kind of figure that one out. Anyways, so the input string length right here, it's a good thing I have these little tricks, see, to remind myself. But the input string, like the reason I chose this model is because it has some of the highest limits, and I think their input limit is like 30,000 or like 14,000 or something like that. And like, look at what I'm feeding it, right? So that's kind of why I'm showing this stuff, so that we can all just kind of see it. Anyways, let's see what this gives us. Oh, sweet. See? Okay, so I just realized that there's going to be a caveat to what we're doing here, because these are all coming out in high to low order. Every time that I limit this, it's always going to either pick from the top or the bottom of the list. But let's just say what the really stressed out real estate genius has to say about the Calgary markets. Okay. Where to begin? Sigh. Okay, let's take a look at the data. As a stressed out real estate agent, I'll try to give you some high level insights, but keep in mind, what does this say? keep in mind there's a lot to analyze in this massive data set. Okay, what else do we have? What else do we have? Median, blah, 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 blah. Bunch of mathematical stats, trend analysis. There appears to be a slight upward trend in rental rates over time with some fluctuations. Let's see what else they say. The highest rates are seen in the latter part of the data set around... Okay. Interesting. That sounds like a little bit of hallucination, folks. Because there's nothing in there from 2020 or 2022. It's all from, like, right now. Okay, so... I don't know where they're getting this stuff from because the data frame doesn't really make reference to months too much, especially not in what was fed to this large language model. Now we did feed it some addresses, so, and we know that we're working in the bottom 500 in the data frame, so we should be expecting these high values. But that's interesting. What was their last statement? Please keep in mind these are rough estimates and might not reflect the actual market situation. As a stressed out real estate genius, I'd consider you to consult with local real estate agents and do your own research before making any decisions. Wow, what a nice guy. Okay, let's see what a stressed out real estate genius that never hallucinates has to say. Ooh, way more concise. Okay, based on the real estate data we provided, here are some stats. Median high-end rentals. Rates okay, so it's sticking to the facts, not talking about where or when. Lowest ones, yeah, because we're in that tail 500 of the data frame. Rent increase. Over the past few years, rental rates have increased significantly. Now, this may not be a hallucination. I mean, maybe this large language model has contextual knowledge. Maybe they know general rental market history for Western Canadian cities. Maybe they recognize that these $3,000 per month rental rates are higher than what is in fact the norm, and we know they are because we're looking at the tail end of the data frame. So that's interesting to note. Average rent, there you go, that's just math. Discounted rentals, that must be these must be ones where they don't seem to fit the same pricing range as similar properties. Maybe we'll prompt it to talk about that more. New developments are focusing on high. See, is this hallucination? Is this interpretation and opinion? What is this? Room shortage? Is this an opinion based on the ratio of rooms of rental listings actually coded as room for rent relative to apartments, condos, townhouses, basements, main floors, houses? Short-term rentals such as air. Okay, so again, is this demonstrating contextual knowledge? Probably. Like general contextual knowledge that I didn't feed it? Yeah, probably. Talking about Airbnb and stuff. Location. Rental rates vary significantly depending with downtown and trendy neighborhoods. Okay, that's just a general statement. Let's ask it about the discounted rental rates. Okay, provide additional information relating to the that you identify. Let's see. Okay, folks. Let's see what, what? Where are we? Yeah, let's go like that. And then let's go like this. Yeehaw! As for the discounted, okay, let's just review this. Average, median, most common rental prices range. Rental price trend, again, talking about trends. Okay, discounted. Foreclosure sales may have been sold as foreclosures. Seasonal adjustments. Owner-occupied rentals. Okay. All right. Let's just get rid of this for now, and let's just move on, because the point here isn't to get it perfect. It's just to have kind of a bit of show and tell, and to do some demonstrations. But that was a bit of an interesting one. Okay, so let's see our prompt here. You are a very concise yet accurate. Now that's a little bit of my humor there. Concise yet accurate. Stressed out real estate genius that never hallucinates. Okay. Now, if any of you are new to the language of large language models and AI, when we talk about hallucinations, that means that they invent data. Okay. So a classic example that I've run into, and you can induce it quite easily, is if you feed the AI something like a time series, like I have values for Q1, Q2, Q3, and Q4, like seasonal average temperatures, right, for spring, summer, winter, fall. And you're missing summer, right? But you have spring and fall. And you're like, put the 4 seasonal temperatures into a graph. But you only fed it 3 because you're missing summer. The AI, generally, if you don't give it additional instructions, it will extrapolate the summertime value. Now, in my experience, it will tend to average between the other values, like between spring and fall. But there might be some models out there, some LLMs, some large language models that are able to identify and differentiate seasons and know that summer should be higher than both spring and fall. Perhaps by the same difference that winter is different from spring and fall. You know what I mean? So it's interesting to see how and when the LLMs hallucinate, which again is tantamount to inventing data points, but you can explicitly tell it not to, right? You can explicitly say, don't try to fill in gaps, don't extrapolate. You can give it an option, like a cop-out. You can be like, in the absence of data, ask for more information, or something like that, or both, you know. So, you know, you can do stuff like that. But let's just move on and see what we got. Let's see what we got. Okay. Sigh, fine. He's still stressed out. There's a lot of data here. I'll try to give you some stats that might be useful. Okay. Minimum and maximum rental prices. All right. Average rental price. All right. Median. All right. Well, that's pretty interesting. 14 rows with missing okay, so just incomplete listings. Maybe they didn't want to fill out the utilities stuff, or because there was a house or something, you know. Unique rental prices. Okay, so yeah, because, you know, we're not looking at that many, right? That's it. I hope you found something useful in there. Now, if you'll excuse me, I have better things to do than analyze rental data all day. Okay. Okay, mister. Let's see what else you have to say for yourself. Okay, let's make this a little bit more easy to read for you people out there in the wilderness. All right, let's see. You are a very concise yet accurate real estate agent that never makes up, extrapolates, or arbitrarily fills in numbers or other data. Okay. Rental price variation. The data shows a relatively narrow range of rental prices from 3,200 to 13,000. This indicates that the rental is somewhat stabilized. Okay, all right. The is approximately 34. Okay, what else? What else do we have? Are based on a limit. Okay, that's good to note. Yeah, total number of. Yeah, okay. So again, just bear in mind, folks, that we've been looking so far at just kind of like the tail end, that is the most expensive rental prices only. Okay, so let's run a few other items. Let's look at all of the factors and maybe limit this to the first 1,500 rows. Let's see how big this is going to be. Okay, so this is all the stuff that's getting fed. Okay, so we're down to 400,000. This is going to be way too much. Yeah, see, rate limit error. Okay, all right. And again, we're going to be starting from the top, so just bear in mind that we're going to be looking at the cheaper houses this time. Or the cheaper listings, that is. Let's see if we get any juice here. Oh, it looks like we might be. Oh, and just remember, we're starting with the smartest prompt down at the bottom. And then we'll work our way sillier this time. Okay, I guess it's thinking a lot. I mean, we fed it a wider variety of data, right? A wider... Ah, come on. Okay, how much did I give it? Requested 34,000. Okay, see, so it says that I'm asking for 34,000 tokens. The limit is 30,000. Did I get timed out? Am I gonna get... Okay, folks, after a bunch of screwing around, I found where the limits are, and we're gonna be picking 100 rows from somewhere in the middle of the data frame. There we go. Not the ends anymore. So let's just get going, and remember, we're starting with the smartest prompt at the bottom. This is what our data looks like. Let's see what we get. Okay, based on the data provided, and again, remember, the last several examples was looking exclusively at the price column, right? So now we're feeding it entire listing stuff, right? Bedroom count, bathroom count, square footage, address. So let's see what we got. Based on the data provided, here are some stats. Median rent, okay, median rent range, okay, so 900 to 1,600. That's fine because we took that middle chunk. 100 rows. Most common bedrooms, the most common number of bedrooms is 1 to 2. 59 out of the 120 that got looked at. 120, huh? Okay. Most common square footage, 500 to 1,000 square feet. Again, with the 120 rentals. Average price by neighborhood. Downtown 1,500. Beltline 1,600. Mount Royal 1,550. Seaton 1,400. Sage Hill 1,300. Rosemont 1,250. Cool. Pet friendliness, a third of them are pet friendly. Utilities, a quarter of them include utilities. Most common amenities are in-suite laundry, underground parking, balcony. Let's see, what else do we got here? Maximum occupancy. Have a maximum. I don't know where it's getting this from. Maybe it's extrapolating that the number of bedrooms is the maximum occupancy. I don't know where it's getting that. I also don't know where it's getting this primary occupancy thing. We did see it hallucinate or extrapolate contextual knowledge about Airbnb before. We don't know if that's what's going on. Lease terms. 1 to 2 years. I don't think I included that data. I don't know how it would get this. Based on that, not represented. Let's look back at that data frame. See? Like, there's nothing about lease terms here, or starting dates, or commitment periods. See, there's nothing here about balconies even, or any of that stuff. So it looks like there is a bit of hallucination, or it's imposing its contextual knowledge. Okay, let's check out another a different level of behavior. Okay, so notice how they get more kind of like less concise and more informal. Let me get to work since I'm stressed out. I'll crunch some. Keep in mind are based on. Oh man, based on a few. It might not be comprehensive. Okay, whatever. All right. Price distribution average. Yeah, looks about right. Median, lowest. Yeah. Oh, and it tells what kind. So the lowest is $900 per month, and it's a studio in the Beltline. The highest is $1,625, and it's a 3-bedroom townhouse in Mount Pleasant. It's not bad for a 3-bedroom townhouse in Mount Pleasant. $1,600. That's pretty good. Most common bedrooms is 2 at 1/3. Most common bathrooms is 1 at half. 12 rentals with 3 or more bedrooms. Utility inclusion statistics. Okay, amenities. Again, where's it getting this gym, hot tub, private garage, fireplace, balcony? Where is that information coming from? I don't see it. I don't see where that's coming from. And I put this together, so I'm telling you it's not in this data. Okay? I can't help but wonder if it's not accessing the internet. I think for some of these items, it probably has referential knowledge to like Google Maps and like just like probably everything that's on Google Maps is probably accessible to this large language model. But whether that means that it can find out what kind of amenities different apartment buildings might have, I don't know. Most common neighborhoods are downtown, Capitol Hill, and Beltline. Yeah, makes sense. Least common are Hamptons, Winston Heights, Copperfield. Yeah, that makes sense. I mean, not really, because, well, it does if you consider that Copperfield is probably outside of the range of rows that we selected. And same with Winston Heights and Hamptons or whatever. Yeah. Yeah, so all that stuff makes sense. Let's try another behavioral parameter. With the data set you provided about rental price, here a few median, just a bunch of bullet points. Really most common basement suite at 37. That's interesting how this one says that the most common is the basement suite at 37, even though it's looking at the same data set. Very interesting. Very interesting. Okay, let's see what the last one is, and I think we'll call it quits with this. With the data set you provided, I can give you some stats about this and that. Wow, it's not acting all stressed out and crazy interesting. Again, just a bunch of really kind of hard math stats. Nothing really too interpretive here. Again, it's going with the basement suite. Talking about skewed price distribution. Okay. So that was a little bit of a skim on how easy it is and how these large language models can be used, and this is actually not even scratching the surface, because what I've demonstrated here is a really kind of Mickey Mouse version of something that I'm still learning, but it's called a RAG model, and it uses a third referential data source, kind of like what I've injected here, but if you kind of like turn this into a whole universe in and of itself that the prompt could talk back and forth to based on a whole other set of reasoning, then that's kind of like what we're talking about. But I'm not there yet, so maybe in the future. For now, I will be doing another video soon, maybe tomorrow, about running these exact same Calgary rental data sets through a different machine learning models. I have a video on this channel about running those for predictive modeling through TensorFlow neural nets. But the next video that I'm going to make is pushing them through sklearn machine learning models. So stay tuned for that one, and thanks for watching.